Hey y'all, this lesson is on the distributive property, and I think you'll find it's quite easy. I've already kind of talked about it a little bit in previous videos with adding polynomials. I mentioned the distributive property, and then when simplifying expressions, algebraic expressions, it was also mentioned. So this is just to kind of focus on it a little bit more so you can see more specifically the value of the distributive property, as we'll be using it in multiplying polynomials for the next video. So the distributive property states that when you have a component, we'll call it, directly outside of a parentheses, you're going to be distributing that component via multiplication to everything inside the parentheses. So you've probably seen me do this before. It's kind of like a little umbrella. We're multiplying A by both B and C. So that's all it is. Another method that I really like to use is the box. And with the box, sorry, you put one component on the outside, the polynomial or the binomial, whatever it is, on the top. And it's kind of like a Punnett square if you've ever taken biology. And what you're doing is you're multiplying the top and side and then the top and side. So it's still the distributive property, it's just in a box form. I really like the box because it's very organized, and this will make a lot more sense when we get into multiplying polynomials. For the distributive property, it's not necessarily like necessary, but when we get into multiplying polynomials with 3 or 4 terms, it's really nice to use the box. It just keeps it nice and clean. But it is the same process, A times B and A times C, for your final answer of AB plus AC. So there's that. I do want to go over something before we get into distributing, something that you need to understand about exponents. Just to kind of recall the definition of an exponent, A to the n means that A is being multiplied n times. So if we kind of take that backwards and we look at some examples down here, this is going to really help us for the distributive property and multiplying polynomials. In the previous video, I talked about adding polynomials where the exponents did not change. But in this case, we are multiplying, and when you multiply variables, their exponents are going to change. So I'm going to show you just a little bit of that. These are kind of some exponential rules, just very basic. X times x is going to be x squared, and you'll kind of see a pattern. I'm going somewhere with this. And then x times x squared, by definition, x squared is x being multiplied twice. So we have x, and then we have times, I'm going to change that because that kind of looks like a x squared, for a total of x being multiplied 3 times. And then we have x squared times x to the third. So if I were to condense it back down, x is being multiplied how many times? Oops, so sorry. 5 times. So I'm using the definition of an exponent to multiply these components. So the definition of an exponent means the number of times that the base is being multiplied, which means I've used it here in rewriting it as x times x, and then I'm using it again to condense it. So I'm using it twice. And then for the last one, x to the third times x to the fourth would be x to the 7th. So basically, if we can look back, I'm writing them all down and I'm totaling how many there are for the exponent. What do you notice? What is 3 plus 4? 7. What's 2 plus 3? 5. What's 1 plus 2? 3. Yay! So basically, we're just adding the exponents. We're multiplying the components, but when you multiply, you're actually kind of totaling up all the bases. So let's go to the next page and look at some examples. These are actually the same examples side by side. This is similar to my adding polynomials. I have two methods to show you here. They're both going to get you the same answer, so it really doesn't matter which method you choose when you're working on your own. The distributive method is kind of like the umbrella method. You're going to take this and distribute it to each term, which means 4x times x squared, 4x times negative 5x, 4x times 10. And you'll notice that with the with the 5x, I brought the negative with it. You don't want to drop that. We get 4x to the third, minus 20x squared plus 40x. Now I went kind of fast, so I want to go back and explain. X times x squared is x to the third. 4 times negative 5 is negative 20, and x times x is x squared. And then 4 times 10 is 40, and we have an x. So I'm multiplying the coefficients, and I'm also multiplying the variable term, the variable component. So this is just using good old distributive method. And then on the right, I'm going to use the box, but you're going to see very quickly that it's the same thing. It just looks a little different. I'm going to draw my box. Doop, 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 doop. Hopefully it works. Yep, dook, dook. Okay, and then inside the box is the product. So I'm doing 4x times x squared. Uh-oh. So sorry. There we go. 4x times negative 5x. 4x times 10. And inside the box, the pink stuff, is the product, which is the answer. So my answer is 4x to the third minus 20x squared plus 40x. And that's it. That's all you have to do. Isn't that nice? And you can see that in both methods, I got the same answer. In the next example, all I have outside is a negative sign. What would be the number associated with just a negative? This would be a -1 outside. So if you wanted to write the -1, you can. But basically what's happening is you're taking a negative and multiplying it by each term, which just means you're taking the opposite of each term. So it becomes positive x to the third, negative 6x squared, positive 5x, negative 20. That's all. In box form, you would just have that -1 out front. You would have these on the top. You can do it the other way, like flip-flopped long ways, but the way I did my notes, it fits better this way, so it really doesn't matter what order you do it. This will be product inside, x to the third, negative 6x squared, positive 5x, negative 20. And that's your answer. So you can see that it's not so bad. I have a really fun one on the next example. I'm going to just do the box for this one. I'm going to try to bounce back and forth between the two. Actually, I'm going to change the color of that. We've got 3x squared y to the third, 4x to the fifth y, negative 9xy to the fourth. Got this box. And then inside the box is going to be my product. So in the left box, I've got 3 times 4, x squared times x to the 5th, y to the 3rd times y. Then I have 3 times negative 9, x squared times x, y to the 3rd times y to the 4th. And now you want to check, are those like terms? Can I join those two pink terms together? X to the 7th and x to the 3rd automatically disqualify it. I cannot add them together. So I just write that as my solution, my simplified answer, I should say. There we go. And that's it. It's your answer. This next one I'll do using the umbrella, the distributive property, instead of the box. That way you have a little bit of both. I am taking negative xy and distributing it to each term. So I'm going to actually write this out just to make it a little bit easier on my eyes. Negative xy times negative 5x, negative xy times 6y, negative xy times 9x squared y to the 4th. So I'm just multiplying, not looking for like terms yet, which means that I'm multiplying the components together. So I have a negative times a negative 5 makes a positive 5, x times x, and a y. Then I have a negative times 6, an x, and then a y times y. And then I have a negative times 9, x times x squared, y times y to the 4th. At this point, you want to check and see if there's any like terms that you can join together to further simplify. These look close. Are they like terms? No. No, they're not. We have an x squared and an x, so they're not alike, which means that this is your simplified answer. And that's it. Let's go to the next page. Have some practice problems. If you want to pause it, try it on your own and then hit play to check your answers. That would be a really great idea to practice. So hopefully you've tried these on your own. If you tried them on your own, these are the answers you should have gotten. And I threw in lots of negatives there because negatives are an opportunity for you to pay attention and be very organized in your multiplication. So remember that the negative is going to change all the signs. So there's all the answers. That's all I have for today on this lesson. I hope you enjoyed it and that you learned something new. If you have any questions or need any help, please feel free to ask me and I would be happy to be there for you.